This is Lesson 10, Calculating Slope, and Activity 4, Different Slopes. And in this activity, you're given 3 sets of points, and you're supposed to find the slope of a line that passes through the 2 points for each set without graphing. And so to do that, I am going to make the first point in each case point A and the second point B. And I'm going to do the calculation as if you're moving from A to B, which means that B is the end, and you're going to subtract where you start from where you end. So you're going to take the y value and the x value at point A and subtract those from the y value and the x value at point B. All right, so number 1, you're going to start at 0, 5 and end at 8, 2. So that means you're going to take 0, 5 and subtract that from 8, 2. Now this really isn't a proper way to write out the mathematics. This is just to remind me, in this case, of what I'm subtracting and how I'm setting this up. So eventually we're going to write this formula as x minus x prime and y minus y prime, where x and y are the ending points and x prime and y prime are the starting points. And you're going to subtract the starting points from the ending points. And the proper way to write it is right here. So this is y minus y prime, which is 2 minus 5. So this is the y value minus the y value. So the y value where you end minus the y value where you start over, so this is the change in y, over how much x is changing. And so this is the x value where you end and subtracting the x value where you start. So this is 0.05 and this is 0.82. So you do this calculation right here. And so 2 minus 5 is the same as 2 plus a negative 5. And 8 minus 0. So 8 minus 0 is 8. And 2 plus a negative 5. So now you're adding integers with opposite signs. And so to do that, you find the difference of those two values. Forget about the signs and just view it as having 2 things, 2 positives, and 5 negatives. So 2 things and 5 things. And what's the difference between 2 things and 5 things? Well, 5 minus 2 is 3. And this is going to be negative because there are more negatives. So this is a negative 3 over 8. So the slope is a negative 3/8. Now, I'm going to go through visualizing what's happening as you calculate the slope and as you continue to write the equation using this point right here, the A point or the starting point, and this slope right here, a negative 3/8. Now we've done some of this already, and I'm just using this as an opportunity to remind you what's happening. This is going to be pretty tough, and you don't have to memorize anything or practice anything or do any problems. This is just showing you because this is what we're going to get into, and the more you look at it and think about it and hopefully visualize it, the more it will make sense. So before I get there, the change in y equals a negative 3/8 the change in x. That's what this is telling you. So how much y is changing right here is a negative 3/8 times how much x is changing. Now, you need more information to draw the graph, and you could use either one of these points plus the slope to draw the graph, or you could just draw the graph with these 2 points. But really the idea is to start getting into your thinking what the value of the slope is between these points. All right, so to visualize what's going on, we're going to take the point at which we're starting, which was 0, 5. So x is 0, y was 5. So this starting right here is 0, 5. And the first thing we're going to do is move that point to the origin. So this point's going to move down to the origin. And that's what you're doing. This is the reason I want to show you. That's what you're doing when you figure out the slope. You're taking y minus 5 and over x minus 0. So what's the change in y? And this is talking about the slope triangle. And what's the change in x? Well, the change in y is y minus 5. So you have to take away these 5 units, move this down to the x-axis. And there is no change in x. You're already on the y-axis. You're not to the left or to the right. So you don't have to move this point at all. So this change in how much y is changing given how much x is changing in the slope triangle is equal to -3/8. And so y minus 5 over x minus 0 is x, equals a -3/8. And so what this tells you is the change in the vertical length is a -3/8 times the change in the horizontal length. And the change in the horizontal length is the value x in this case. So y, so if I subtracted this 5, I have to add that 5 back. So y is equal to -3/8 x plus this 5 right here. All right, so how can I visualize this, what's going on as I write this out? Well, I'm going to move the starting point where we started to move along the line. That's this equation defines that line. This is the equation for that line. So the first thing we're going to do is move this to 0, move it to the origin. And then we're going to write or place 2 points based on the slope. So in both directions. So the slope is a -3/8. So right now we're working with just this part of the equation. Y equals a -3/8 x, just the proportional part of this equation. Once again, y equals a -3/8 times x. So you could move to either this point right here. So this is a +8, -3. So it's 8 along the x-axis and 3 along the y-axis. One of those two has to be negative, and the other one has to be positive. You can do it either way. So it's a +8, -3, or a -8, +3. Both of those moves will get you to 2 points that are on this same line. They have to be on that same line because they're defined by this relationship, going through 0 and having a slope of a -3/8. So if I start here and I go out 8, -3, +8, -3, or I can say -3, +8. Actually, I want to go the other way. So I could say a +3, -8, and +3, -8. All right, so the next step. Now I have to add this 5 in the equation. Remember, you started with 5. That's what this means. This is where this line crosses the y-axis. So this is known as the y-intercept, and actually it just happens to be right here in this case. So you have to move both of these points up 5 units. So move them both up 5 units and draw this line. So this is going to be a parallel line, but now it passes through a +5 on the y-axis because that's the y-intercept. So this line now is defined by this equation. This is the equation for this line. And so what are here's the start and here's the end. The end, if you remember, was 8, 2. So 8 along the x-axis and 2 along the y-axis. And so that slope was 8, -2. So +8, -2. Or from here, remember we actually started here and we ended here. And so then we took these values and subtracted these values from the ending values. All right, so these are the steps that I followed. I moved the start to the origin. That's just like sliding the slope triangle that we've been talking about all along. You're sliding that slope triangle from wherever it is, and this is the vertex of that slope triangle. That's the starting point. You're sliding that to the origin. And then I'm going to apply the slope in both directions. So then I took the slope and I moved in both directions the value of that slope. So I either moved out and down 3 or to the left and up 3. And so I placed those 2 points. Then I applied the y-intercept to both points. And so you have to add those 5 units back. So this line then slides up to here. And finally, I graphed the endpoint. And the endpoint is right here at 8, 2. All right. seems tough and I'm undecided whether I should do this or not. But I'm just going to go through it, and the more times you look at it and think about it, the easier it will be. All right, so number 2. It starts at 2, -1, and the line is going to end. You're going to move from 2, -1 to 6, 1. So x is 2, x is 6, y is -1, y is 1. So again, this is not really the appropriate way to write a math equation, but it just reminds me that I'm going to subtract the starting amount from the ending amount. So this is -1 minus 1. I'm sorry. It's 1, yeah. This is the ending amount, subtracting the starting amount. So it's 1 minus -1. Sorry about that. This is 1 minus -1 and 6 minus 2. So this is the ending amount, and this is the starting amount. So it's 6 minus 2. So now calculate that out. And remember that 1 minus a -1, you can use the inverse operation, which is addition, and the additive inverse, which is +1. So this turns into 1 plus a +1. Well, 1 plus 1 is 2, and 6 minus 2 is 4. So this slope is 1/2. All right, so now I'm going to draw this just like I did before. I'm going to draw this again. And remember, the first step is to move from the starting value. If you remember, that starting value was 2, -1. So it's right here. X is 2, y is -1. So that's the amount that you're subtracting from the ending values. And so I'm going to move the start point to the origin. So I'm moving it to the origin by doing this calculation. Take whatever the value is for y, subtract -1, which is the same as adding 1, by the way, and then take whatever value for x and subtract 2. That ends up at the origin. And this is the calculation to get to the equation. This seems long and hard. It's not actually that bad. It's longer because there's several places where you have to use the inverse operation and the additive inverse. But if you just work through it, y minus a -1 is the same as y plus 1, x minus 2, x minus 2. So this is the same now. And if you remember, you can say that the change in y is 1/2 whatever the change in x is. So whatever the vertical length is 1/2 of whatever the horizontal length is along that slope triangle. So then you can move this over just by saying that y, the vertical length is 1/2 the horizontal length. It is equal to 1/2 the horizontal length. So you can write that out now. The vertical length, y plus 1, is equal to 1/2 the horizontal length, or the change along the horizontal length. All right. So now you have y plus 1 is equal to 1/2 of x minus 2. I'm going to rewrite x minus 2 as x plus a -2, and this is why this begins to seem long, because it's a lot easier to keep track of what's going on if I'm multiplying 1/2 times x. So I have 1/2 x and 1/2 times a -2, and actually I should have written this here as plus a -1, because 1/2 of a -2 is in fact -1, and you can rewrite that as subtracting a +1. I should have written one more step in here, but it just gets long if you include absolutely everything. All right, so y plus 1 equals 1/2 x, and here I rewrote it as plus a -1. And if I added 1 to move up to the horizontal axis, I have to subtract that 1. I have to take that 1 away from the y. So this becomes y equals 1/2 x plus a -1, and also I have to subtract that 1, so minus 1. Well, subtracting 1 is adding a -1. This is why this seems long, a bunch of tiny little steps here. So y is equal to 1/2 x plus a -1 plus a -1. Well, a -1 plus a -1 is -2. So you end up with y equals 1/2 x plus -2, which is why I wanted to change this to adding a negative value, because this shows you where the y-intercept is. So the y-intercept is going to be right here at -2, right there. All right, so this is long. I would go through this several times, think about, make sure you understand each step. And the beginning of it is just moving the starting point to the origin. So now what are we going to do? We're going to take the slope and we're going to move in both directions the value of the slope, both to the right and to the left. Well, to the right, that's 2 units along the x-axis, 1 unit along the y-axis, so it's 2, 1. And to the left, it's a -2 units along the x-axis and a -1 unit along the y-axis. So this has to fall on the same line. They are the same slope. Both of those are both of those are positive 1/2 slope. A negative and a negative is going to give you a positive 1/2. All right, so the next step, if I subtracted 2 down here, I have to subtract 2 from both of these points to get to the line. So notice I'm going to subtract 2 here. You're going to end up at the start. I'm also going to subtract 2 from this point. So I'm going to subtract 2 here, and I'm going to subtract 2 here. Actually, it's better said as I'm adding -2, because I have to get to the actual line that's defined by this equation. So I add -2, add -2, and now I'm going to graph the ending point. The end point started at 2, -1, right here, and we ended at 6, 1. So that line has a slope of a positive 1/2. So it's 1, 2, 3, 4, and that's 2 units in the y direction. So that's 2 over 4, which is 2/4, which is the same as 1/2. All right, so here's the steps once again. All right, so we're going to do this one more time. So the third set of points, again, it's b minus a. So we're starting here, so we're going to take these points away from where we end. So it's these points minus these points. So it's b minus a, and again, this is not really the best way to write this. It just reminds me how to set it up. So it's the y value for b, which is -5, minus the y value for a, which is -2. So it's this -5 minus this -2, and it's this -1 right here minus this -3, minus this -3. So it's this -1 minus this -3. Well, both of these can be rewritten as using the inverse operation, which is addition, and the additive inverse, which is a +2 and a +3. So both of these can be written as inverse operation and additive inverse. So a -5 plus 2 would take the absolute value of these, 5 and 2. You have 5 things and you have 2 things. That means you have a difference of 3 things, and it's negative because you have more negatives. Down here you have 3 things and 1 thing, so that difference is 3 minus 1, but it's a positive, 3 minus 1 is 2. It's a +2 because you have more positives. So that gives you a slope of a -3/2. All right, so here's the slope, -3/2, and we're going to use the starting point, which is a, -3, -2, to go through and visually show what's happening as you go through this these manipulations to get the equation. All right, so move start to the origin. So the starting point is -3, -2. I'm going to move that to the origin. That's what you're doing when you say the change in y is y minus a -2. So y minus a -2 is adding 2 to this point right here. So this is going to move up to the horizontal axis, and then it's x minus a -3. That's the same as x plus 3. So you're going to add 3 this way to get to the origin. Okay, the next thing I'm going to do is from the origin, I'm going to place a point in each direction using the slope. Oh, I'm sorry. Here's working through that equation. I'm not going to go through this step by step, but I would encourage you to do that. And you'll see that it's not that bad. And I changed everything to halves. So here's 2. I changed 2 to 4 halves. And this part right here, this is a negative 3 halves times 3. Negative 3 halves times this 3 right here. Everything else I think is understandable. And notice that the y-intercept is a negative 6 1/2. So it's going to be down here at negative 6 1/2. So it's going to be right here when we get to that point. All right, so I'm going to go to this point, and I'm going to use this slope in both directions. So the x value is positive 2, and the y value is negative 3. It's a negative 3 halves. So positive 2, negative 3. 1, 2, 3. And a negative 2 and positive 3. 1, 2, 3. So positive 2, negative 3. So it's positive 2, negative 3, or negative 2, positive 3. So you can move this negative down here and treat it as negative 2, positive 3. All right, so these are the 2 points moving the value of the slope in both directions. So now what I have to do is I have to subtract, I have to add a negative 6 1/2 to each of these points, because I have to move this down to the y-intercept and also move these 2 points down to their appropriate place. This is a translation, so you're going to translate this line a negative 6 1/2 units down. You're going to add a negative 6 1/2 units. So translate it down, so this point goes here, it's a negative 6 1/2 units, and this point moves at negative 6 1/2 units this way to here. Connect the points, and here's the start. Start at this point. The start also has to be on the line. And finally, so apply the y-intercept to both points. And finally, the last step was to graph the endpoint. Well, the endpoint's right here. So we go from this start to this end, negative 1, negative 5. All right, so I hope this is a way for you to visualize it. We're going to develop or write these equations more and more and more. And if you have some visual idea of what's going on, it should help you understand as you work through these equations. All right,